right, so as we were talking about in class, we define the derivative of f of x as the derivative, this f prime. We don't say f prime, we call it the derivative. The derivative of x is this limit. Okay, the limit is delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Remember, those are those 2 points at x and 1 at delta x, and we're getting delta x closer to 0. So the difference between what we did earlier in class is we're replacing that c value with any x. This is the definition of a limit. The derivative can give us the instantaneous rate of change. So whereas slope gives us average rate of change, this gives us the rate of change at an instant. So derivative is a slope, but it's instantaneous. There's other notations for derivative. We use f prime of x, that's what it looks like, but it's the derivative of f. We can also do the derivative of y, if we're using y instead of f of x. Delta y over delta x, which we've seen before. Dy over dx, that's just replacing the delta with d. This says taking the derivative with respect to x of a function. And then this last one we don't use as often, but it's the derivative with respect to x of a function y. So if you want to find dy dx, there's some wrong things here. It's the limit as delta x approaches 0 of delta y over delta x. And that's the same thing as the limit as delta x approaches 0 of our functions. We call that the derivative. So let me show you how this all works out in a problem. We want to find the derivative of this function using the definition of the derivative. So derivative definition is f prime of x equals f of x plus delta x minus f of x all over delta x. This is the same formula that we were working with earlier, just instead of c, we're doing it for any x. So now, we'll get into this. This first part, this f of x plus delta x, that means we're plugging in x plus delta x into this function, into both spots. So we're going to do x plus delta x cubed plus 2x plus delta x. I'm going to put that in brackets just so you can see that separating. Then we're going to do minus f of x. So minus, and then f of x, I'm going to put that in a bracket. X cubed plus 2x all over delta x. That's the calculus part, getting that plugged in. The rest is algebra here, okay? So the calculus is actually easy. It's the algebra that's hard. Okay, we want to take x plus delta x to the third power. This is easiest using that Pascal triangle expansion. Remember, the coefficients are 1. Let me do this in green so you can see it all here. The coefficients are going to be 1, 3, 3, 1. And then they'll be x cubed, x squared, x to the first, and then no x. And then the other direction, delta x cubed, delta x squared, delta x, and then no delta x, and they're all positive. So that expansion, super helpful. We're going to distribute the 2, so plus 2x plus 2 delta x. And then over here in purple, I'm just going to distribute that negative, minus x cubed minus 2x. And we'll put this all over delta x. Okay, some stuff cancels out. X cubed, negative x cubed, 2x, negative 2x. And at this point, you see everything left has a delta x in it, so I can factor out a delta x from the top. So we get 3x squared plus 3x delta x plus delta x squared plus 2 all over delta x. I forgot the limit part of this. Remember, this is the limit. This is out in front of this whole thing is the limit as delta x approaches 0. That should be in front of all of this. I'll write it in the next step. Sorry about that. Okay, so once we get here, here's this limit. M's, I can't write M's today. The limit as delta x approaches 0. That should have been on the front of all of these things, and I forgot it. Delta x's cancel. So we get 3x squared plus 3x delta x plus delta x squared plus 2. Now remember, we're taking the limit as delta x is approaching 0. We can plug in delta x. This is going to be 0, and this is going to be 0. So our limit is going to be 3x squared plus 2. That's our answer. The derivative of our function f is 3x squared plus 2. And then we can use this to find the slope at any certain point that we wanted to. But remember that original function f up here somewhere? This function f, oh, sorry. I don't know what happened there. This function f has this for its derivative. I'll show you another example in the next video.